Welcome to a new learning clip by Shed Coders. In this session, we'll explore the fundamental aspects of Python lists. We'll focus on the basic operations and leave some more complex operations for some dedicated clips. For this purpose, I've set up a simple application backbone to illustrate these concepts.
Let's begin by looking at how lists are represented and displayed. Note that, for more graceful printing, I've imported a pretty print library. In our example, we have two primary data structures, a list of numbers and a list of people. The list of people is made of dictionaries, but we'll delve deeper into dictionaries and their use in a separate video clip. Now I'm executing the program, and you'll see the numbers and the list of people printed in their initial state. The first crucial method for lists is append. As the name suggests, it allows you to add a single item to the end of a list. Let's see an example. Note that I'm using an AI agent to help me generate the code. Most of the time, simply adding a comment in the code is enough to get exactly what I want. Here we go. The AI proposes code to append 25 to our list of numbers and append a person named David to our list of people. Since the AI proposal is perfect for this example, I just save and execute the program. Observe that 25 has been added to the end of the numbers list, and David has been added to the end of the list of people. Very straightforward and very useful when you need to add just one item.
But what if you need to add multiple items? You can, of course, loop through the items and append them one by one. Nevertheless, there's a more efficient way using the extend method. This method extends a list by appending all the items from an iterable, for example, another list, to the end of the current list. Let me add a comment here. The AI agent provides an example that extends the numbers list with 35 and 40, and also adds two new people to our people list. After saving and executing, you'll see that the numbers list now includes 35 and 40 at the end, and the two new people have been added to the end of the people list. Pretty useful, right? So far, we've only added items to the end of our lists. But what if we want to add an item at a specific position? For this, we use the insert method. Let's look at an example. The AI provides the code to insert an item at the very beginning of the list, that is, index 0. This time, however, I'm not accepting the code as is because I want to insert the new number and the new person at position 2, which clearly means it will be the third element of the list. When we execute the program, you'll see that the new number appears between 5 and 20 in the numbers list, and the new person appears between Bob and Charlie in the people list. Since we can add elements to a list, it's reasonable to assume we can also remove them. Let's see how the remove method works. Based on the comment I added to the code, the AI agent understands that I want to demonstrate a removal. The proposed code removes the number 10 from the numbers list and Alice from the people list. If I save and execute the program, you'll observe that 10 and Alice have disappeared from our lists. Note that this method removes the first occurrence of the specified value, and in the case of dictionaries, they must match exactly. When you want to retrieve an element from a list, you use the method pop. Pop works by index and assumes you want the last element if no index is provided. In the example, I will retrieve the last and the first element from the numbers list and print them. Now, as I start doing the same for the people list, the AI agent suggests the code correctly, avoiding me the time to write it. Let's run the program. Notice how the elements are printed and removed from the lists. As a last topic for this video, I'll show you one of the most important operations you can do on lists: sorting. As usual, as soon as I type the comment, the AI agent suggests a possible scenario, which is almost perfect. For a list of integers, sorting is straightforward. It simply sorts by value, as shown in the example. For a list of objects, such as our list dictionaries representing people, we need to specify by which field of the dictionary we want to sort. The AI agent suggests using a lambda function. While lambda functions are beyond the scope of this introductory video, suffice it to say that it allows us to specify a key for sorting. In this case, a score or similar field within each person's dictionary. To make it a little more complete, let's sort the people list in reverse order. So, I'm setting reverse equals true in the sort function. Finally, to avoid interference from previous operations, let me comment out some of the earlier code. Now, if we execute the program, you'll see the list of numbers sorted in ascending order, and the list of people sorted in descending order, based on the specified key.
This concludes our initial overview on Python lists, with practical examples to help you grasp the core concepts. There's much more you can do with lists in Python. I encourage you to experiment with these methods in your own Python environment. Have fun and keep exploring with Shed Coders. Code your future, now.